Okay. So here we go with solving today's problem. All right, Brian, what do you think? What do I do?
I.
It is I.
What?
Okay. So
I told him the answer.
So a few of you already knew, and that's exciting. That's exciting. But some of us didn't know. And so
That's very weird.
doesn't that look cool?
No.
This is like the world's most super coolest bin that we're gonna fill out. Okay.
Wait, what?
So when you guys were like 2, maybe 1 or 2, most of your parents probably started to teach you to count. Like 1 Cheerio, 2 Cheerios, 3 Cheerios. Hooray! So y'all learn how to count. And just counting in itself taught you about your first number system. Does anybody know what that number system is called?
Whole numbers.
Real.
Natural numbers.
Natural numbers. Okay? So our counting numbers are natural numbers. So we're starting in the innermost circle here.
Should we draw this?
I would. Isn't that awesome?
Wait, how are we supposed to? How are you post it?
Okay.
Let's just
Can you post it on your website so I can print it? Because it's impossible.
So our first set of numbers.
I'll just make sure you're right.
Are natural numbers. So let me give an example. It would be like 1, 2, 3, ... Keep counting forever. Now, I heard somebody say the next set of numbers that natural numbers falls into. Real? Natural numbers does fall into real, but this next circle.
Integers?
Whole numbers, because what's the difference between the set of natural numbers and the set of whole numbers?
Whole numbers include 0.
It does include 0. So now we have the basis for which our numbers revolve, well, not really revolve around, but are centered around, which is 0.
And then there's integers.
Very good. So when we look at whole numbers and their opposites, we now have integers. And integers really includes the whole numbers and their opposites, so I could go like -3, -2, whoops, left out my negative, try again, -2, -1, 0, 1, 2, ran out of space, ... So now we're up to integers. What do you guys think is next? Rational and real. Very good. Okay, now we all know whose paper to stare at while we're taking our next quiz, because somebody's on fire back there. Nice job.
Obviously on our own.
Okay, thank you very much. We wouldn't ever look at anybody else's paper. Okay, so rational numbers falls within the realm of real numbers. Real numbers basically divides into 2 types, rational and irrational. So rational is really anything we could write as a fraction if we're going to like the very simplistic definition of it. Irrational are numbers that we cannot write as a fraction, like square root of 2, square root of 7, pi, e, non-repeating, non-terminating decimals. Stuff like that. Rational numbers are repeating or terminating.
So are irrational numbers real numbers?
No.
They are. Irrational are real. They fall in the real number category. Then we have the new one that Brian talked about and a couple other of you already knew, and that's imaginary. And do you see how imaginary does not fall within the realm of real numbers?
Because they're not real.
Okay, now they're not real, like they're not part of the real number system, but they're not imaginary like your imaginary friend you had when you were 2. Okay, they're not like fake numbers or numbers that don't really exist. They do exist. They're just called imaginary. And with imaginary are based off the imaginary unit, which is I.
It's got like the double thing.
And we're going to talk about what I represents in just a second. This is our imaginary unit. Now, if we were to put a real number together with an imaginary number, that gets a little complex, doesn't it? Yes, that's a complex number. Okay? So our complex number systems are made up of all real and imaginary, or we can put them together. So a complex number might take the form of like 2 plus 3i. That's a complex number. And with our complex numbers, we do put them in a plus bi form. And we'll talk about, well, let me tell you what that means. The A represents the real part of the number, and the B represents the imaginary part of the number. And we always write them in that form. So whenever you're presented with a complex number, or you come up with a solution and it turns out to be a complex number, you would always put the real number part of that number first and the imaginary part second. So we always write our answers in this A plus BI form. So let's go back to our warm-up. Oh, all right, after y'all finish copying. And we'll solve this problem. So we move the 1 over, and we get -1. And we take the square root of both sides. And when you take the square root, you get plus or minus. So we get x equals plus or minus. And this square root of -1, we just talked about it. This is our imaginary unit. The square root of -1 is defined as I. So when we're simplifying any problems, or simplifying any radicals that have the square root of a negative, it would simplify to be an imaginary number. Okay, so this is plus or minus I. So if we had a problem such as this one, x squared plus 9 equals 0, we'd get x squared equals -9. So when we take the square root of both sides, this is what we think of it as. We think of it as plus or minus the square root of 9 times -1. What is the square root of 9? 3. And what did we just define the square root of -1 as? I.
That's the imaginary part. Oh my gosh, this is so
the solution to this quadratic equation is plus or minus 3i. Okay. Now, there's nothing awe-inspiring about this new number system. It just we defined it. Here we go. It's based off this, and now we're just going to manipulate things that have the square roots of negatives in them. So, just like when your parents taught you to count Cheerios, it wasn't exciting and the world didn't change. It was just a new number system to you.
I used to love Cheerios.
I love
So-
Cheerios.
Cheerios are really, really good.
Yay, I'm glad we all enjoy Cheerios. Alright, so, let's look at this first problem. No. Alright, square root of -36. So we are thinking of this as 36 times -1, so 6i. Alright. Square root of -20. We're going to think of -20 as, we're still going to break this down. We know we have the -1 in there, so that's going to give us an I. And then 20, what's the largest perfect square that divides into 20? 4. 4 goes in there 5 times. So the square root of 4 is 2. The square root of -1 is I. And it leaves a square root of 5, a 5 under the radical if my baby will open. No, it's not behaving at all. Okay, there we go. And when we're simplifying a radical, and we are able to simplify part of the number and pull out the I is going to go in between our number and our radical. And this is the form we leave it in. If you did it the other way, the I might accidentally look like it's under the radical, and then that's something very different. Okay? So that's why it's just widely accepted form to put your I in between. Okay? Alright, what about this one? Square root of -7. What do you guys think that would simplify to?
7.
Okay, can we take the square root of 7? No, so it has to stay under the radical. And the square root of -1, which is what this... Yeah, it's I. So it's I root 7.
Okay, and then you always put the I first.
Yes, the I would always come immediately before the radical. Yes.
Why would it be a difference if the I was under the 7 in this occasion, since there's only...
If it was under the radical, that would be the square root of I, which is very different than I itself. It's like the fourth root of -1 instead of the square root of -1.
Oh, yeah.
So it has, yeah. All right, you try.
Ooh, I got this.
Yeah, it's gifts.
Pretty sure I got this one.
Dude. I'm pretty sure the calculator's in the system.
Oh wait.
Your calculators will do these. You have to tell your calculator that I now want to play with imaginary numbers. And you can put it in imaginary mode, which means, will I let you use your calculator on this part of the test quiz? No.
Absolutely.
Yes.
No,
Wait,
that's
this is
what
on
it
a quiz test
means.
tomorrow?
But if
I mean, test tomorrow. Test quiz.
I
no,
read
next
the wrong one.
you're September 10th. Today is the 2nd, so we're a week and a day away from that.
I thought it said.
So it's okay.
And that's the.
All right. So if you hit the mode button, if you look down somewhere in that list, do you see it says A plus BI form?
Oh wait, we're doing that.
You could play with it. We're not going to use it on a test or quiz, so I don't know that I would practice with it on homework, because then you would be ill prepared for your test or quiz. All right. So, but if any of you reached for your calculator on a problem this simple, I might have a hissy fit.
I got it.
Because the square root of 25 is just 5. The square root of 16 is just 4. And when we think of this as -1 times 25/16, the square root of -1 is I. So it's just 5/4 I. And it takes you a lot less time to think of the answer than it does to punch it in.
Oh my gosh, I put the I with the 5.
Okay, is that wrong?
Wait, that's right, isn't it?
Matthias, what do you think?
I think it's right.
I think it's right too. It's right? Yeah, you can write them either way. I normally do it like this.
Wait, so both of them are right? If we write it like the one with the I with the 5, is that right on the quiz?
It is fine as long as it's not like 3 plus 5i over 4.
Okay.
And this is not really an A plus BI form, is it? Is it currently separated into a real part and imaginary part? Now, okay, this used to be a big deal in the math world. It's no longer as much a big deal. I've seen actually on standardized tests that be the correct answer. But, you know, when I started teaching 20 years ago, this was a big deal, and they pinched a fit, and you must write it like this, or you're wrong. You know, it's not such a big deal anymore. The fact that you know that both of these are complex numbers, and if I gave you this and asked you what the real part was, you could tell me 3/4. And what the imaginary part is, you can tell me 5/4 I, right? So, yeah.
They wouldn't give you both of them, would you?
No. You wouldn't have both of these as options on a multiple choice. This is what I've seen the last couple of multiple choice things I've looked at. Imaginary units are not usually on the SAT. If any of you already started SAT prep, you're getting... Wait, nobody's in
Jake.
Okay, Jake has. That's right, Jake has. Good job, Jake. All right. Well, it would be beneficial for you, you know, if you want to do as well as you possibly can on the test that helps determine what college you might get into. If that matters to you, we can all be extremely successful no matter what school we went to. That's right. That's right. Woo! Okay, yeah. Okay. Did I watch the Georgia Tech game?
I watched it.
I did not go. I know.
They played some unknown schools. Like
Yeah.
Wofford.
Yeah.
You didn't go to it?
I did not. I was camping with my family this weekend. So. Yeah. You would probably enjoy my kind of camping. We lug a 35-foot fifth wheel with us. We have air conditioning and kitchen and
We
a
just go like,
bathroom.
we just go like.
We call it camping. All right. So those of you that are starting to prepare for the SAT, it can only benefit you. And we will start doing some SAT warm-ups at some point this year. Probably we'll spend more time second semester than we do on it first semester, because usually you guys will start taking the SAT seriously your junior year. So those of you that are freshmen, you've got a ways to go. But I would recommend that before you do take it, you review geometry, because there can be a good portion of geometry on there, and for my 9th graders, you will not have done most of that since 8th grade. So I would at least review it if you did not take a class. That's fine. Okay. We have next thing we're going to look at are complex conjugates. Complex conjugates. So complex number, and conjugate. To find the conjugate of a complex number, all you have to do is negate the complex part. So we talked about this a second ago. When we're in complex form, that's the a plus bi form, that first part is your real part. So we wouldn't negate that. The second part is your imaginary part. And to find the conjugate, we negate the imaginary part. Now today, this is just vocabulary. Tomorrow, we're going to use complex conjugates to simplify problems. Okay, so here's our first example of this. If you were given 2 plus 3i, what would the conjugate of that be? 2 minus 3i. If you were given the complex number, negative 4 minus I, the conjugate would be negative 4 plus I. All you're doing is negating the complex part. So the real part stays the same. The complex part switches to the opposite. The real part stays the same. The complex part, the imaginary part switches to the opposite. I did say complex. No wonder y'all are all confused. That should be imaginary. Let's fix that. Yeah.
That's so handy.
Especially if you mess up. All right. So there we go. The imaginary part.
Now I get it.
Okay. I saw a lot of confusion. I was like, what? What's wrong with that? The imaginary part. Okay, so here we have 7i. So what would it become?
Negative
7i. Here we have 6.
6.
It's still 6, isn't it?
Yeah.
Because it has no... Right. Is this a complex number? Is 6...
Yes.
Okay, if we had to best describe it, what would you call it? A natural number. But do natural numbers fall within the complex realm?
Yes.
Yes. This is 6 plus 0i, isn't it?
Oh my gosh.
Oh,
Yeah. So let's go back and look at our crazy then. Did natural numbers fall within complex? Everything. Every number you know now falls within complex. Okay?
Oh, yay.
Yeah.
I'm trying to write
What
this.
does that change?
Are you being recorded right now?
What now?
Huh?
Definitions.
Okay, if you guys, those of you that have your workbook, if you would turn to page 296, we're going to do 1 through 8 and 17 through 22. And then on 297, 1 through 3 and 12 through 14. Now, this is the green workbook, and some of you have it and some of you don't. So here we go. Here are the problems for those of you that don't have it to look at.
You guys.
What page did you say?
It's page, hold on, 296, numbers 1 through 8, and 17 through 22, and then page 297, numbers 1 through 3, and 12 through 14. Okay, so Any of you watching this on video, you probably want to fast forward because it's about to be 5 minutes of silence.
Probably.
On my locker, it's right up there.
Ideally.
So it's on.
Those are the problems on the overhead if you don't have your work.
So should we start?
This page in Hispanic
Should we
selection.
start?
I think this page.
If you look at the calendar, it tells you on the calendar exactly what we'll be using in class for classwork and what
Real
term
numbers?
So you're welcome to bring those anytime. Now, we are a day behind on the calendar, so this is actually Friday's assignment.
I was a little scared. Last I looked at the calendar.
It's like everybody's doing
No. Well, your homework was to review your perfect squares.
Yeah.
You see now why?
Yeah. Is everybody?
Are we just writing the numbers?
Yeah, put them where they go.
Alright.
I think we've only 2 in
Are we just like a slow class?
Wait, so we like separate like 3 in the I? So like 3 and 3 in the I.
Okay, on this first group, it falls under real numbers, imaginary numbers, or complex. If we were thinking of this as a set, the complex would be the universal, right? Everything falls in the complex.
So we just do that.
So it's going to go somewhere within that box.
Solid shape. Not say the fun
Have you entered those?
I made it all the way through third grade.
I looked
Number
last
6.
night. I'm
What
getting.
did I say?
No, I looked this morning. Yeah, I looked this morning. The only grade is
What other grades?
We just have a point right there. Yeah.
the only grade is no. So we have like yeah, put it
What happened? Oh, we
Oh my god.
You just here.
Oh, you did get rid.
How
bad it is.
Stupid, so she's stupid, have negative
Stupid than you're
They were working out, so.
I told you.
Is out.
Alright.
Stop.
Hey, which one is that? Number
Not
2?
funny anymore. Remember this?
Yeah, you're.
Oh,
Okay.
Wait,
And then we got one wrong?
do we put the whole thing and what is it?
It's going to go, yeah. You
Well, like each part.
can't separate it.
You can't.
It's
Okay,
one
so
number.
3 plus
Where does that
5.
one number go?
I got 27.
What are we doing?
Oh my god.
What kind of question is that? What? What do we get? Oh, 28 out of 30.
You wanna keep it?
Sure, I'll do that.
What do you guys
No,
do?
29.
Is it because we didn't cover episodes?
What is it?
Oh my god.
Did he? Are you? Oh my god.
I'm interested there. I'm not.
Oh, we put that in the wrong.
What would they get? Another
We got the
40.
right answer.
They got.
You good?
Yeah, no, yeah, we were just like,
Regular there.
we changed it. Dang it.
Oh yeah, I forgot about this.
Everybody said it.
So
You
plus
remember how I
7.
said it was supposed to be plus 9 and you're like, no,
So
it's
it's supposed to be plus 7.
Oh, this is supposed to be 40.
Maybe it's probably not. It's plus 5.
That's a killer.
You wrote the wrong.
We should ask. It is.
Do you want to see
You got 93.
Oh yeah, you need to really know X. So you have to sit in
Yeah, she really got an accident right now.
Okay, after you take a glance at your campground task that I handed back, if you guys could finish up these problems, and we're going to go over them in just a moment.
Oh, goodness. It's going to be my week.
This will be. Well, our next test is what?
Since picking it up.
It's like.
You lost it.
I don't even know.
They don't
Oh, that's right. I asked them. I'm 16.
If I did
This world is
I actually guessed pretty well that this would be.
What's
Yeah,
14
why-
How much was our last homework?
Your first time was worth 20.
Yes. Alright, I'll have like an 85 minute.
I got 60. Okay, so 63.
This is the same thing as this.
I got 33. So it'll be 3 times 2.
Because this is
So it'll be 9 times 2.
So if you just have this.
Really? That's what
Exactly. You told me.
I got 6 by 2. Because like, well, no, I'm so sorry. Because you would do 2 times 3.
So I thought you were saying we want
86
1.3 by negative
is what
1.
my-
Yes, that's what's subtracted.
So 84
So that's
was
what I
my
thought
test.
you were
Oh,
talking about.
I got 84.
And I saw you were doing this, so I think that that'd be like 5. If I knew you knew that this was the same sign, then you went through and changed all your signs. So I knew you had it.
I don't know. I'm gonna know something. Every time I try to do something.
Yeah, we got
Saying live.
Yay.
Hardly. Okay, you cannot notice that. By the skin, if you like, it turns white.
Okay, here we go. 3 plus I is complex. It has a real part and an imaginary part. It's complex. Negative 17 is just a real number. More specifically, we would call that an integer, but that does fall under real number. Square root of 7 is also a real number. It's irrational. 9i is an imaginary number. Negative 6 minus 5i is complex. It has the real part and the imaginary part. Negative 7/8 is rational, and it would fall under the real numbers. 6.492 is also rational, and it would fall under real numbers. Negative square root of negative 25. The opposite of the square root of negative 25 is negative 5i. So it's going to fall under imaginary. Does that make sense? Okay. Complex conjugate, all we're doing is changing the sign of the imaginary part. So these were quite, is that an 8? Okay, good. So this becomes negative 1 plus 9i, and this becomes 12 minus 5i. Okay, the square root of negative 32 breaks up into 16 times 2 times negative 1, which is 4i root 2. 2 times the square root of negative 18. Well, negative 18 I would break up into 9 times 2 times negative 1. So I can take the square root of 9, which is 3, and the square root of negative 1, which is I, and that leaves a square root of 2. So it's 6i root 2. Okay, this is the same as negative 1 times 1/9. The square root of negative 1 is I. The square root of 1/9 is 1/3. So it's 1/3 I, which you could write as I over 3. But normally we'd write it as 1/3 I. The conjugate, all right. This one was not written in a plus bi form. We must write the real number part, the imaginary part second. So it should be negative 3 minus I. Did anybody get tricked and just change the negative 3 to a positive 3? I would have if I was going fast. Okay, this is really negative 4 plus 3i, so its conjugate would be negative 4 minus 3i. And then the conjugate of positive 11i would be negative 11i. Yes, ma'am.
On number 1, I did 8 times 4,
Uh-huh.
and then I did 3 to 4 is 2.
Yeah.
And I left 8 in there.
Okay, 8 is not completely simplified. So
Oh, yeah. Okay.
you have to go with the largest perfect square that divides into the numbers. Yes, Sid?
What is the purpose of changing it to a congregate?
Okay, today we're learning the vocabulary. Tomorrow we're learning the usage. Tomorrow we will have division of complex numbers, like we might have 2 plus 5i over 3 minus I, and how do you divide them? And in that's where the use of the conjugate comes into play. We will multiply the numerator and denominator by the conjugate of the denominator, therefore eliminating the imaginary part from the denominator. And an imaginary number is really just the square root of negative 1. And can we leave a radical in the denominator?
No.
No.
I followed like half of that.
Yes.
Is this going to be with the polynomials on the test?
This will be in a different section, but yes, it'll be on the same test. Yes, ma'am.
Why is it from 1/3 to 3?
The square root of 1 is 1. The square root of 9 is
3. Oh,
Okay.
Okay, he didn't understand either. I asked him and he didn't understand.
Someone didn't say
Alright.
square roots.
Whoops.
You're
Okay.
not nice. Cam, I didn't understand. No.
I forgot to erase my answer. Okay, now we're going to take and do some simple operations with complex numbers. Today we're just going to do addition and subtraction. We're doing simplifying, addition, and subtraction. Tomorrow we're going to do multiplication and division, which is where that conjugate will come into play. Alright, so we have 2 numbers here, right? We have 2 complex numbers. This is one complex number, this is my second. And we're going to add those complex numbers. Well, if we had never talked about I today, and I just gave you this problem and you thought it was a polynomial, what would you do? Combine like terms. And you get 6 minus 2i, wouldn't you? Okay, that's what you do.
Oh, okay.
Yeah, it works just like adding and subtracting polynomials. When we add and subtract complex numbers, we add the real parts together first, and then we add to the end of that our imaginary part of the complex number. So we have the real part and the imaginary part, and it's just, we get it from adding the real parts together and adding the complex. So just like we did with subtraction of polynomials, we treat it the same way. So when we have subtraction here, we're going to change everything to the opposite and then combine our real parts and our imaginary parts. This only has one real number, so that's what I'll start with, the real number part, negative 2. And then we have 6i plus a negative 3i is 3i. And that's all there is to addition and subtraction. There's no, secret trick to it. It's quite simple. Okay, this is in your workbook on page 304. We're doing 1 through 4, and they're right here. And then on page 305, 9 through 11, and they're down here. If you don't have your workbook, you try those problems. Even if you do have your workbook, try those problems. Alright, take a look. Did you get 8i? Negative 13 plus 2i? 3 minus 4i? 8 plus 14i? 5 minus 7i? Negative 1 minus 10i? Negative 7 plus 10i? Awesome. Okay, so tonight your homework is out of the textbook, and it's going to be what was on the calendar for Friday, because we're going to be a day behind until we get to your test. And I'm not going to reprint the calendar. So it's out of the geometry, which is your green book. It's on page 437 and then on page 444. But on 437, you're doing 18 through 21, 32 through 35, 76 and 77. And then on page 444, we're doing numbers 46 through 51. And that's it for you tonight. Okay, so you can go ahead and get started on that now.